Hello everyone, this is now the time is 12:27 a.m. and let us read about combinational circuit. In combinational circuit, the basic thing that we read is the first one is called half adder. Okay, it is called half adder. So half adder. In half adder, what are the things that we need? The first thing that we need is one is XOR, and the second one is AND, AND gate. These are the basic gates that we need. This is XOR gate and this is AND gate. So how to draw combinational circuit, how the circuit looks like for adder. Let us see. So adder will look that as we are having XOR gate. So there will be on the output part, there will be two things. One is sum and other one is carry. In adder, we have in while adding we find carry. So sum and carry. Adding means sum, output will be on the sum and carry. So here XOR is needed. So let us first make XOR. This is our XOR. And the next one is, it is saying we need one AND gate. This will be our carry. This will be our sum and one will be carry. Now let us make the input. Input will be like this. A, B. These are the input, and this input will also go to AND gate. This is the circuit of half adder. So now let us write its formula. If we see here S, so S is the XOR of A and B. So we can write S is the XOR of A and B. Okay, A and B. So this one we can write the formula for XOR A and B. So this is given as A bar B plus A B bar. Right? This is S. So this is sum. Now come to carry. In carry, both the inputs are going for the NAND operation. AND operation. So this will be A dot B. So this is our sum and this is our carry. Now this is the special gate and this is the universal gate. Now if we have to implement using NAND, so how many NAND we will use? This is the basic gate, this is the special gate. So using the universal gate like NAND and NOR, so how many NAND we need, how many NOR we need to implement the half adder. So NAND, how many NAND will be needed? 5 NAND will be needed to make half adder. Okay. And NOR, for NOR also 5 NOR will be needed to make half adder. So this is the half adder. Now come to full adder. Let us see full adder. The second one is full adder. As the name suggests, full adder. So in full adder we will have 3 inputs. Okay, 3 inputs and carry. Sum in the output side we will have sum and carry, and there will be 3 input. So for that we will be needing 3 XOR gates. So here 3 input, and so here we can say that we need here XOR gate in how many number? 2 number, and we need AND gate we need AND gate, and also we need OR gate for adding. Since we are using 3 inputs, so we'll be using OR also, because we have to add in carry, we have to add for C and AB both. So let us try to make the circuit of half adder, full adder. So for making full adder, the first one is that we need is one XOR, and again we'll be needing another XOR. 2 XOR is given. So let us make the input. This is A, this is B. B input is given. Now this output is going to the next XOR. And here another input is given, that is C. Okay. And from this we are taking, this C will be connected to the next XOR. Here is our C. Okay, and this will be our sum. Now A XOR B and XOR C means, here we can say it is A XOR B XOR C. We will be deducing the formula for this expression. First, let us see what the carry will come out. Now this C is getting AND operation with XOR A and B. A and B, okay. Now this will be get, here is what we need OR. Okay, OR is there, and another AND we need, and this AND we are taking from here. A, from A we are taking, okay, A, and from also B we are taking. This is our AND operation of A and B. And at last, now we can take carry from here. This is C. So let us write the expression of C. So C can be given as, see, A XOR, here we can say it is A XOR B. Means A XOR B one input and C one input. Means here it is, here we can write A XOR B and with C. Okay, so A XOR B is in AND with C, and we have the OR operation. OR operation means plus. And now let us see. Now these, for this AND operation we are getting the input from A and B. So this will be A and B. So here we can write A and B. A and B. So this is the full adder. This is the diagram of full adder. So now how many universal gate, or how can we make full adder? So full adder can be made, if we use 2 half adder, then we'll make 2 half adder makes 2 half adder makes 1 full adder. Okay, and here if we are using the universal gate, so there in half adder we were using 5 NAND or 5 NOR. So making full adder we need 9 NAND. 9 NAND gates, fine, and 9 NOR gates. Okay, so let us revise one more time. So here we can see this is our full half adder. In half adder we need one XOR gate and AND gate. For XOR gate we need two input and one XOR here. So in the output side we have the sum and carry. Sum is the operation of XOR, means A XOR B. Now if we are reducing this, if you reduce this expression, then we'll get A bar B plus A B bar. Okay, this is our sum part. Now the carry, now carry will be the operation with AND gate, then A dot B. For making the half adder with the universal gate, so we need 5 NAND if we are making with NAND, and 5 NOR if we are implementing with NOR. Now come to the full adder. In full adder we need there three input terminals are required, means we need two XOR, one NAND and one OR. So here one XOR is used for the two input A and B, and now the XOR of A and B is provided with the another input called C. So the sum part we are getting, sum will be A XOR B XOR C. So if we reduce this expression, if we expand this expression, so we can write A bar B bar C plus A bar B C bar, okay, plus A B bar C bar plus A B C. This is the A XOR B XOR C. Okay, first implementing the two input and leaving the third, and then implementing first and third, leaving the second, implementing second and third and leaving the first, and without implementing. This is XOR sum. And now on the carry side we will have to take input from the A XOR B and one with C, and next both the input from A and B. So our sum will be A XOR B and with C plus plus means the OR operation, the AND of A and B. So to implement full adder we can either use two half adder. Two half adder makes one full adder, or if we are implementing full adder with NAND gate, so we need 9 gate, and for NOR gate we need 9 NOR gate. So this is all we have in this video. See you in the next video with some amazing topic. Till then, good night and take care. Bye.